Hello everyone and welcome to another Fusion 360 tutorial. Today we will be seeing how to create a parametric CAD CAM. So in order just to make it easier for us, just in order to follow your progress and things like this, you should send me your email account linked with Fusion. If you go here and click just like preferences and things like that, you can just check it. So I will share with you this folder, this project, in fact, this CAD CAM demos. And you can just click on my part, hit copy, make a copy, then you just click over your, well, I'm just going to make copy. You say that you want it to copy here. And then, for example, this copy that you've made right now, you say rename and you put, I don't know, Pepe Martinez Rovira, something like this. Okay. So each of us, we will have a part and we will have it here. So you can just like share with me as an easy way to just share everything. Okay. So we will be working first of all on a parametric cut. Very easy, very fast, because you should just like know. We select the plane. We'll create one circle here, another circle there, and just a slot. I have this command. It's for me, it's Control Alt S. Okay. Just to remember for you, you go to slot. Here you see my command. You click to the 3 points, pin to shortcuts and change keyboard shortcut, and you can just like configure it. Then we just like give some dimensions, for example. No, let's say, okay. This one, it's like 12. This one, it's like 20. And then you can just like click to D, select this one. Instead of putting here a number, select this one. Okay. And then this is going to be the parametric length. Okay. We will say 100, it doesn't matter. And then we will just extrude this profile 10 millimeters. Okay. Then we will create a center hole. Just create a sketch over this face. Some middle line. Okay, this is just like a fast way to create the center of this, to find the center. Okay. Why do we want to find the center? We want to find the center. Okay, so this hole is going to be -5 millimeters. So it is important to just put it in a center with like this kind of references, because if we are just like going to just change the parameter, you will find it here just to make it parametric. If you don't do it like this, maybe you follow this hole in here, it's going to be not in the center position. Okay, so we will go to modify, change parameters. We'll create one parameter that it's called, for example, L, that it's the total length. The expression in this case, it is going to be 100. And the comment, it's going to be length of the slot. Sorry, this is not valid. Total, no, mid length. Okay. Length. Okay, because it is the middle length. Then we go to our first sketch, right click, edit sketch, and here double click and just tip M. Here you will see it, enter. Okay, so what's nice of this is that if we go to FX and we say here, I don't know, 50. Okay, I've modified this part, and you can just like create a lot of references and just put it in function one of others. Okay, so we'll begin with, yeah, with 50. It's nice. You can just put the number you want, always that you respect the more or less the shape. Okay, so now we have our design made. We are going to save. Click OK. and then we're going to hit manufacture workspace. Okay, so here it's going to begin the interesting CAM part. I will just explain a brief concepts, and then in class we will just be seeing it more in detail. Okay, so the first thing that we've made in order to be able to create a CAM, it's like to have a solid body. You can just import it, but in this case, the nice thing is to just design it in Fusion, so you can just change it and maintain some things. And on the manufacturer module, you will see here milling, turning, adaptive proving, fabrication, and utilities. We are just going to be seeing milling today. Turning will be on next sessions, because why we will be seeing turning in next sessions, because you've seen it in practical laboratory more or less, so we want just like to give you more time to just see milling. Okay, so here we have our part, and the first thing that we need to know is that we need to create a setup that says the machine where the zero is going to be found of the piece, and how many material do we have around in order to machine this part. Okay, so the goal is to get this part finished. So we need to just like tell the machine how many material do we have and where is the zero. Okay, that's the setup part. Okay, also you can just like create NC programs manually if you want, or just like modify or just change the coordinates and things like this, but we are not going to see it. And then here we have, like, as you can see, the 2D block and the 3D block, and then the 3D. So the most important thing to notice, and the difference between 2D and 3D, it's basically 2D strategies are going to machine the geometry that we say without like taking care of how much is that geometry of, for example, the depth, or the or if here you have another hole or whatever. Okay, so if you select this contour like this one and you say, hey, machine it, it can say, okay, I'm machining it outside or inside. Okay, we'll be seeing this. Instead, 3D strategies will be concerned about the geometry that you've created, and will just like avoid to just crash the tools in your geometry. We will be seeing, first of all, the 2D ones, because are the easiest ones. And if you want to just like take more in-depth learning of CAM, you can go to 3D, okay? But basically, with the concepts that you're going to see in 2D, 3D, it's easier, okay? So 2D is more flexible, because you can do it just like whatever you want with more control. 3D, you have less control, but it's like more automatic. Okay, so we will be seeing 2D because it's like the easy and the clearest way to just begin. So the first operation before just like creating the strategies is to create the setup with which we're going to work. So we will hit setup, and automatically you can see that Fusion creates us a box. Okay, so this is the stock. Okay, a box that it's going to see this yellowish material that you can see here. It's the material that we are working with. And what does it say? Okay, it says relative size box. Okay, because that's important for parametric. You need to say relative. Okay, if you say fixed, when you just like change the parameter, it is not going to work. You can say also from solid and just like put functions from there, but the basic thing is just relative size box. What are we saying? Okay, add stock to sides and top bottom. Okay, so to all the four sides and the top. Okay, the top and the bottom. Then we are saying, okay, stock side offset, so 1 millimeter to each side, and 1 millimeter up and down. Okay, so that's nice. But okay, so in this case, what we're going to make, it's like just add a little bit more material on the bottom. I can see. Okay, here to top we'll say just like 20 millimeters up. Okay, yeah, that's normal. 1 millimeter. Okay, so basically here we are seeing that this the top is the Z axis, so we need to change it. Okay, so we'll go first to setup and select that the Z axis, because we are going to work like this. The machine is going to cut this, cut this, cut this, and cut this. We'll just select model orientation. Now we want to select, for example, Z axis plane and X or Y axis. Okay, this doesn't matter. So first of all, Z axis or plane, it doesn't matter. Now we have it like pretty good. We have it on the center, it's nice, but we need to select the X axis. That it's nearly selected, but here we have it. Okay, so as you can see, Z it's up, it should be up, and you have like X and Y. Okay, so that's nice. What's important of this? Okay, can we just get this 0 just proving the part with our milling machine? Yes, because we will just touch here, touch here, touch here, and touch here, and get the center. Okay, you cannot say, like, for example, a point here if you can just like prove it that you are there. So you need to just like be able to go to this point or very close to this point and know that this is your 0. Okay, also an important thing here is that we are saying that it's the stock box point. Okay, so we are working with the stock box point. So if we add 2 millimeters up to the stock and you just touch the 0 of the stock, you will know it. Okay, so here we have this selected stock. I think now we put here 3 millimeters. You can see that here on the upper side, or if we put like 5, it's increasing. Okay, what we want in this case, it's not the top, we want 1 millimeter, but we want the bottom, because we are taking this with a vise. Okay, if you don't remember, just check the theory. We are just working with a vise, so we will say like 5 millimeters. It's more than enough. And here it says us the total height. Okay, so we'll say 4 because it's enough, and that's more standardized profile. Okay, also if you are just checking your manufacturer material or your provider material and he doesn't have this, for example, or 292 width or 42 width a profile, if you need to make lots of parts, you can just like play here and say, hey, I just want 2 millimeters here or 2.5 millimeters here. So you can, maybe these dimensions are more realistic. Okay, we hit OK. So we have our setup ready. Okay, you should be seeing something like this: the Z pointing up and the Y and the X just like on the plane of your part. Okay, so with our setup ready, we can begin to just machine it. So usually the first operation on just milling, it's like making a face, clearing this face of here with your milling machine in order to have a flat surface. Okay, so the first thing that we are going to make is just, first of all, facing this part. Then we will be just making some holes, some pockets. Okay, some holes, some pockets. Then we will be profiling these holes to have it like perfectly machined. And finally, we will just like profile, just take out the material that we have of the stock a little bit more deeper than the part. Okay, so we don't need to just like cut it through it. We just like need to machine a little bit more in order to then flip this part. Okay, we'll just be seeing this on the next session, flipping this part and machine it to the top surface, the bottom, the original bottom surface, that will be the top. Okay, so first of all, we usually begin with a facing operation. We go to 2D, face. Okay, so now we have this context menu. We'll be seeing here different things, and the first one, it's called tool. So we need to say the machine, which tool are we going to use, okay? So you can just like define the tools that you're going to work with in the workshop, if those are what you have. But in this case, because we are not on the workshop, we are just like working with what we have. We'll go to select, choose samples. And here you can see that you have all of these are tools, okay? All of these are tools ready to be used, okay? So manufacturers put here their tools with the feeds and speeds, so you can use them, okay? A nice thing of this context menu is that you can go to operation and say, hey, what do I want to do? I want to face, okay. What else do I want? Okay, I want, for example, a flat or a facing bar, okay? And dimensions from, we select diameter, we can say like, for example, 3 to, I don't know, 55, okay? And here we can see all the tools that are according to that parameter. So a normal facing, how is this set? Just like these plates, these big just facing mills are these ones, the 50 diameter, okay? So you can see it's big one. So with one operation, we will have everything finished. It is very nice to use them. They are very efficient and they are just like cheap compared to carbide tools that we'll be using for just like facing, okay? So if your machine has enough power, just use this kind of tools if you can just like face in one operation or 2 or 3, okay? So we hit OK, and you can see that automatically the parameters here have changed. You can see here the spindle speed, the surface speed, the ramp, everything, okay? So in this case, because this tool, it's basically thought to be used as a facing tool, these parameters are going to be good for us, okay? So we'll be seeing why maybe we can just like change some parameters, but these parameters will be okay with a machine that has enough power, right? So then we go to, so this is okay. You don't need to touch anything. You can just, in order to just like uncheck it, here it's saying, hey, do you want to use coolant or whatever? Say disable, okay? Because when someone is checking your G-code, he will be seeing the coolant here, okay? So then we jump to geometry selection, okay? So what do we want to face? If we say nothing, it is going to select everything, okay? A nice thing about Fusion, if you stop there with the mouse, you can see, okay? The default stock area, it's the one that it's not like selected. And if you select the edge, the round edge, it will be just be doing the same because the plate is really big. But if you have like super large area workpiece and you say nothing, it will just face everything, okay? So that's right. Then we will go see here, okay? So this is what makes 2D like the most important part to not crash our machine. So what do we need to say? Okay, so usually this clearance height, retract height, feed height are okay. The most important ones are the stop height, okay? Stock top, that's right, the stock top, and the bottom, okay? So the top height, it's the one that it's going to begin machining, and the bottom, it's the last one that it's going to be machined, okay? So if we select here, you can see that here, I've changed this one, okay? Okay, you can just like do it visually, okay? But the order should be clearance, retract, feed, top, okay? So if we go to top height, that it's this one, that it's this one, you can just like move it a little bit up, okay? So we can say like 1 millimeter over the stock top if we have like just a little bit incline our part or whatever, okay? And then the bottom height, it's the model top. That's right, because it's the highest part of our model, okay? So here we are saying, hey, the stock top, it's over 1 millimeter, and the model bottom, 0 millimeters, okay? That's right. What are we just configuring here? We are configuring how is the machine going to be working. So here it is saying, hey, the tolerance, we can just like put it like this. It's better because it's the arc, the tolerance arc, okay? So past direction, here you can see like the degrees and everything like this. We can say that it's 0 degrees. You can just change this parameter if you want. It's a nice parameter to change, usually for different finishes and things like this. Pass extension, this one it's really important. Usually I just like put here at least half of the diameter of my tool. Why? Because I don't want my tool finish like go up over my part. I want it to do it up outside on my part. So usually I will say, for example, this one it's 50 millimeters. I will say like 26. Okay, that's enough. Stock offset, it's okay. I'm not sure that our stock it's always going to be like the dimensions we told. So you can just like give an offset to our stock. So this should be the upper tolerance that that the material manufacturer has given you. Okay, but in this case we can just leave it at 0. Step over. The step over it's how many what's the distance between each pass. Okay, so we will be seeing right now how does this affect. Okay, so we will do it one with 47.5 that it's, I don't know the formula, but it's here like 95% of the diameter of the tool. And then we'll be seeing the changing this parameter. Okay, direction both ways. You can use either climb or conventional, whatever you want. If you use usually climb, it's just like to remove more material, and conventional you get better surface finishes. Okay, and multiple depths. Multiple depths, it's a very important one. Maximum step down, we are going to say 0.6 millimeters. You need to know how to play with this, and with this tool you can just like put here like 2 or 3 millimeters for sure. Okay, but we're just going to work with 0.6 in order to see how is it going to affect our cam. Okay, and finally you have here linking. In this case we are not just like worried about it. In other cases we will see how to just like linking affects to our strategy. Okay, so we hit OK. Okay, must be above. Now it's okay. Okay, so when you get this kind of errors, you can see. Okay, so here we see if we are on the side, you can see here we have 1, 2, 3, 4 passes. Okay, we now hit right click, edit passes, and here we say 1 millimeter. Hey, now it's only 2 passes. Okay, so that's what it's going to affect us. How many material are we removing each time? We can leave it like this. Okay, and also you can see here, this is the transition, and you can see here that the distance from here to here is the one that I've told you, hey, here you should like leave a little bit more than the tool radius, not diameter, radius. Okay, so we will go to here that it's simulate. We'll click stock. Standard, it's okay. You can just like put it transparent or whatever you want to do. But for me, this one, it's okay. We say, okay. Well, we will just slow the speed and put it like this. And here we are seeing how is it machined. That's the first pass. And the second pass. Right? And there you can see when you can see the profile is that the machine is like on the top of your part. Okay, so that's finished. Okay, so we have our part faced. That's good. We're going to close. That's tool 1. Okay. So now we have this ready. We can just like go to 2D. No, we will be just like doing these 2 holes. First of all, we'll be just doing it with a drill. And then we will just contour them to get a proper size. And then we will be pocketing this part, okay? So we will go to drilling operations, drill, okay? We need to select the tool. Okay, so the tool was like the hole was 12 millimeters. So first of all, we're going to say, hey, I want to do a hole. Okay, I want to use like no contour bore, no. Well, we will be using a spot drill, but we will be just do it directly with a drill. Okay, for in milling, when you're just milling parts, you should first of all create a spot in order to the drill to be just centered. But because we are going to do it like smaller than the hole should be, and then we will be contouring them, it's not a problem. Okay, so we're going to say drill, enter, and the range it's going to be between 9 and 11 millimeters. Okay, okay, there's no tools there, right? Why? Okay, yeah, I need to go to samples. Sorry. Okay, so we go down. That's a mess, but first of all, there are inches, and down there are the metric ones. Okay, so here you have stainless steel. We are working with aluminum, so we are just going to select. I think this should be here. Okay, aluminum samples metric aluminum. Okay, so we are going to select the 10 millimeters. Okay, because we are just like going to be working with 12 millimeter hole. Okay, so we're just going to leave. I don't remember that. Diameter 12. Okay, so we're just going to do this. These feeds and speeds are okay. The geometry, we're going to select these 2 holes, or we can select same diameter. So when we select one, in theory, it should be selecting all the rest. Okay. Well, if not, we're just going to be like traditionally 1 and 2. Okay. He's showing us how it's going to just drill it. Okay. Heights, important. We just need to do it more. We just need to penetrate more. So you can go to hole bottom, drill tip through bottom. Yes. Now you can see that that's now just drilling through it. You just, okay. But we are going to give an extra minus 0.5 millimeters. Okay. Just in case. And then the cycle. Usually, when working with really hard materials like titanium, inconels, and things like this, you don't want to do what we are going to do here. That it's like pecking. Pecking basically what does is like just penetrate a little bit, go out, penetrate a little bit, go out, boom, 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 until the hole is done. You want to just like do it with special tools and just like go only one through it. Okay, but for aluminum, what's this? No. For aluminum, we are going to usually be working with deep drilling full retract. Okay. What's this? This is going to go pecking depth. The pecking depth is the depth that it's going to do in each like pass. It's going to make until it goes through the bottom. So we can say here like a 10% of the diameter. So 1 millimeter. Pegging depth reduction, don't worry. Minimum pegging depth, it's the same. And dwelling period, it's it's used in order to just like wait down until the chip it's gone out. So we can say here like 0.5 seconds. Okay. We click OK. Sorry, we need to just like check the edit. Here it is. Tell before retag. Okay, if not, we are not going to. Okay, so here we have our strategy. We're going to see the whole machining operations that we are doing. Select 1 and 2. Okay, clicking Control. Select Simulate. Select Play. Okay, a nice thing is that if you click with your mouse with your left button, and then so I'm clicking and then moving right, left, whatever, you can see what it is doing. Okay, I can see here how it is working. Okay, boom, boom, boom. You see it, right? You see it how it is working. Boom, 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 boom. It's just pegging. Boom, 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 boom. Okay, so that's nice because the chip evacuation is really good. In this case, that's what I've been thinking right now. We will just we are going to drill through all the material, okay? Because the device is going to take this part with this side and this other side. So right click, right, escape. Okay, when you're just in simulation, just hit escape. Right click, edit. In heights, we're going to select, instead of whole bottom, we're going to select stock bottom. Okay, there we are. And now if we hit simulate, boom, boom, right, boom, 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 boom. More. There it is. And there it is. Okay, so we have more or less this. Okay, so right now what we're going to do is like with the same tool to reduce the number of times that we are changing the tool, we will be just contouring these two holes that we've previously made to our inferior size, pocketing this pocket, and then just contouring this part. Okay, so the first one, it is going to be this pocket. Okay, so we go to select, to the pocket. Okay, you can use adaptive also, but in this case we are just like keeping it traditional. We're going to just, as always, select the tool. We go to operation, open pocket. No, it is not an open pocket, it is a pocket. Okay, that's right. Well, just take these ones out, enter. Diameter between 8 and 12, it's okay. Samples, go down there. Just like, for example, an 8 millimeter tool, it's okay, but for aluminum, here it is. Hit OK. Here we have the fits and speeds, more or less. It's, yeah, for me it's right, 10 RPMs. Here you can see the cutting feed rate. So that's the feed rate, and you can see here the feed per tooth. It's really low, so it's nice. You can see also the surface speed, that it's equivalent to the velocidad de cutting speed. Okay. So then select geometries. What do we want to pocket? This one. Usually when I pocket, I select the area like this, not the profile. I select the area. Heights. We're going to say, hey, I want it to be stock top. It's okay, because we face it, so it's safe here. And then here we're going to say selection, that it's
going to leave to just like permit us to select the height by selecting the surface, the same as the other one. Okay, it then passes. Okay, so in passes it's going to say hi to tell us, okay, the tolerance we want it like this. Don't worry about this. Left climb, that's good because we want to remove material. Finishing passes no, preserve further no. Maximum step over 7.6. It's a lot. Okay, so the step over, it's how many it's penetrating the end mill on the material. So we don't want this crazy step over. You can just work with this, but we are just trying to learn, so we are not going to work with this crazy step over. We will be working with a 10% of the diameter. It's going to take longer, but we are not going to break tools. Okay, so it will be or a little bit more, but yeah, 0.8 millimeters. Yep, 8. Okay, just don't worry about this. Smoothing deviation is just like, yeah, it's okay. And here it's multiple depths. No, and stock to leave. We want to leave radial, but we don't want to leave axial, okay? Because the axial it's going to make, in fact, it's going to make the hole just like not go to the bottom. So here we say 0, okay? At least that's my experience. In radial, yes, because then we will be contouring this as these holes here. And then linking. So that's really important. With typical end mills, you cannot go down like with a drill. So what you need to do is go here and say, hey, I want a ramp. Which type of ramp? An helix. And the ramping angle 1. Okay, we are just like keeping everything really conservative. We are not working like crazy beasts. Okay, we don't have real position, so we can just do anything. And here everything it's automatic, so it's going to work really well. Okay, so the helical ramp, as you can see here, I don't remember if it's right, but yeah, it's what it says here. It's the 1.8 by the diameter. Okay, so that's good. Click OK, and we will see how it's just like creating the strategy. Okay, so there we have it. This hole won't be finished. We will see it right now. So we're just like going to hit, select the 3, simulate, first operation, good, 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 good. And now we're just like pocketing. Okay, you can see it's going down, doing this spiral. Okay, nice. And now boom, 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 it's taking the material out. But as you can see here, it's leaving 0.5 millimeters. Okay, so we're going to hit close. It's okay, it's nice. So now what do we need? We need to contour inside. So these holes, these 2 holes, and this one. So first of all, click here to the contour, the same tool. We told that we will be using the same tool, so that's right. Geometry, this one. And here you can see just this small arrow. This arrow is saying us, hey, it's inside. If you just like put it like this, you're not going to see if it's inside or outside. So you need to just go there, okay? And also this one. That's right. If you need to change it, just click over. Okay, so now it will contour outside. We want inside, okay? So that's nice. The heights. We want to contour until the stock bottom, okay? Want to just like contour everything. Passes, roughing passes. Okay, so here it is the same. We have 0.01, that's better. Finishing feed rate doesn't matter. Finish overlap, repeat finishing passes. Don't worry about this. Roughing passes. The roughing passes, it's like how much am I going to penetrate on the material. So here we want to just like say step over the same as at the pocket. No, the half of the pocket in this case, 0.4. Why is saying this as? Because up here it is the same value. 0.4. Okay, so now it's right. Okay, the normal step over and this one. Okay, how many step overs? We left like 2 millimeters left, so it's 1 by 1. So we will say like 4 step overs just to keep it safe. Okay, and linking, we have pre-drill position. Yes, which one? This one and this one. So the mill is going to go vertically down in these positions. Okay. Also, a very important thing in contour, it's this one. It's finish overlap. Take a look. So finish overlap, what makes it okay? If the end mill is beginning here, 1, 2, 3, 4, okay, because that's the roughing, and 5, the finishing. The overlap, it's like going to advance a little bit more without taking more material. Okay. Why is this important? Because if we end in the same place where we began, sometimes we leave here a tiny spot that it's not wanted. Okay. Okay. So we don't want stock to leave. Hit OK. It's saying us something here. Additive text slim. What is this? Okay. Here we've said a drill. I don't really understand this. That's an end mill. I don't know if it's colliding because of the height. We'll see. We're going to simulate. Okay, so a warning, it's a warning. If you have here, like in red, you cannot do nothing, okay? A warning, it's just like to keep you just warned that maybe it's something it's going to crash, so just take a look. That's a drill, okay. Okay, maybe the drill is in the image, I don't know. One, okay, the other one. This one, that's right, it's the contour, so we're just going to, no, this is the pocket. Hey, he's not selecting us this one. Why? Simulate. No valid toolpath. Edit. Let me just like do it like this. Just to check it. Oh, no. I don't know what this is. Enable feature flags. Additive text slim. Could cause a collision. Let me check. Edit. Geometries. Okay, the geometries are right selected. This is like 12 millimeters, right? And the drill it's edit. It's 10. And this one should be 8. Yes. Okay, I think it is in here. Check, no. Let's repeat it. Sometimes this happens. So we go to contour, this one, and this one. Okay. The tool, it's right. Yes, yes. The heights, we'll just like check just in case to do it. Model bottom minus 0.5. Passes, we will leave it like this. Don't worry, we will change it right now. Finishing. No, the overlap, we want to finish it. 0.5 millimeters. Okay. What happens right now? Okay, it is doing. but it is doing only one and the overlap. Okay, so we want to do it in several passes to get a better finish. We'll go to roughing. We'll go to roughing, maximum step over 0.4. Step over 1, 3, or 4. Let's check if it's this one, the one that it's like not working properly. Oh, 0.5, we can just leave it 0.5, okay? This is more knowing the tools that you're working with than other things, okay? Sorry, 0.5, 0.5. No, it's giving us the same warning. Cannot plunge outside the stock. I don't really know why this is happening, because in theory the tool is like going inside, so we will go and hit cannot plunge outside the stock. Let me go to linking, virtual positions, this one and this one. No. This one and this one. Let's check it. No. So we're going to take out the roughing operations to check if it is going to work like this. No. This says us cannot use tree position because keep tool down is not activated. Okay. Keep tool down. Okay, I think it is. It should be like here. No. Okay, so we are just like going to uncheck this. Click OK. We're getting our proper contour. It's only one pass. Let me check if edit. This happens. Okay, so this is normal. Passes. Multiple finishing passes. We'll just leave it like this. Okay, so this does more or less the same as roughing. No, it is something strange. This. Okay, so we'll just like leave it like before, and we will just do it on another case. Okay, so here we have the contour. We're just like going to hit and simulate everything again. So here we have the facing, drilling, more drilling. Okay. So there we have it. So now we're going to check if we can just like contour this one without any problem. Okay, a nice trick is just like to click, right click, duplicate. We have the same here. Right click, edit, just check the geometry. We now select this one. We go to heights. We go to selection. Okay. My bottom reference. Thank you very much. Selected contours. Yes. Now selected contour. It's the one that we've selected. Here we want at 0. And now we have here just like this contour here. Let me check if right now it is working, because maybe it's that these holes are too tiny for just like making several passes. Okay, so it will be like colliding with everything. So let me check if here it is going to work. No, we will check it later. Okay, maximum step over 0.5 and number of step overs we'll say like 4. Okay, don't worry. Definition is greater. Okay, do you want to ignore? No, we don't want to ignore it. We want just like to reduce this one. Okay. And this one works. Yeah, maybe it's that this hole it's too tiny for this other tool, or that the length of the cutting flute it's less than the hole. Okay, so don't worry about it. You have seen it here. You have seen that you can just do it. Okay, so finally we are just going to profile the part, and we'll see what we get. Okay, so here we have like again, we can just like use a 2D adaptative. It's yeah, we are going to use the 2D adaptative. It's a really nice strategy. Okay, so what it's going to do is just to keep the feet of the tool constant. Okay, so you can see here. Okay, we go to 2D adaptative, 8mm. It's right. Geometry, this one. What do we want to machine? The outside, right. Heights, we go to just like selected, no. Model bottom minus 1mm in order just like to take it on our vise. Okay. Passes, here it is the important parameters. Tolerance 0.001. Optimal load, I usually use 10% of the tool diameter. Okay, so this will be 0.8. This is a conservative way to do it. Okay, but it's going to work. Stop to leave, radial, it's okay, but actually we don't want to leave any. Okay, and then the linking, it's okay, just leave it like this. Okay, boom, 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 bam, here we have it. Okay, so now we are going just like the finishing, it's this one, just duplicate it, drag it down here, edit, geometry, it's not this one, it's this one. And the height, just check always the height. Okay, it's the most important thing. Selected contours, we're going to select this one and say minus 0.4, a little bit less than the adaptative, so the end of the tool it's not touching down. Okay, so this will give us better surface finishes. Okay, and well, we don't need this many passes, sorry. Edit, here we have it like roughing. We will just say one roughing, one finish. Okay, one roughing, one finish. There we have it. So now we have our part nearly finished. Okay, that's nice. Just click to simulate. Click OK. Drilling. More drilling. Pocketing. Okay, we are going on the spiral and then just taking out the material. Contour, contour, contour. And this is the adaptative. Okay, so the nice thing of adaptative is that it is going to keep the feet of the tool. So this way, this that you're going to see here, the flute. This penetration here, okay, this is the how many the tool is penetrating. It's going to be kept continuous. Okay, so it doesn't matter the shape. It is going to just adapt to it. Boom, boom, boom. Now you can see clack. It's going to do another and another and another and another. Okay, just to give this, and you can see we are just leaving a little bit of material there. Another one, another one. This really effective for what is effective, adaptative. Adaptative strategies are really nice in order to remove the maximum material with only one depth. Okay, so what does it mean? It means that with just penetrating one time, we're just getting all the material out. So this is really efficient. More adaptive, more adaptive, more adaptive, more adaptive, more adaptive. Okay. Boom, boom, boom. This is known also as trochoidal milling. The strategies were not inside. And we have our part finished, okay? Nearly finished, okay? You can see here the small gap. Here you can see the profile of the part. This stock that we need to remove. So the next session, this is like the most important thing, we'll be seeing how to generate another setup with the same part in order to generate the facing operation that will take out all this material. So just to finish, here we have this nice program of this part, and now comes our client says, hey, the part is 2 millimeters longer because whatever. Okay, first of all, always click save just to have a copy and a version there. So what do? Repeat the part? No, you go to design, you go to change parameter, you say here, hey, 2 millimeters more, 52 millimeters. Well, we'll say 100 millimeters more, 150. 50. Hit OK. Hey, our design is ready. We will go to manufacture. And now it's everything in red, don't worry. But our stock is okay. Select the first one, shift the last one, right click, generate. Boom, and we have our CAM program already done with only just clicking generate. That's awesome. Okay. So you can just like work with several parameters. You can also put this diameter as a parameter design function. We can say here, add one, that it's diameter 40. I don't know. Okay. Okay. We go to right click, edit sketch. This one it's 20. It's not 20. It's diameter. Enter. Finish sketch. Now go to manufacture. Left click, shift, left click, right click now, generate. And you have it. Okay, so you already have it. If you do it well, you have the strategies in order to work. Okay, so here you can see the step over. So that's really nice. Okay, so thank you guys and see you.